In March 2026, Anthropic launched its first professional certification. $99, 120 minutes, proctored, and you get exactly one attempt. Fail it and there is no retake button. Almost everything written about this exam sits behind a paywall, which is funny because the official exam guide is a free PDF published by Anthropic sitting on a public link. I read all of it. This series is the study course I wish existed. It is called the Claude Certified Architect Foundations Exam, CCA-F. Anthropic launched it on March 12th alongside a $100 million investment into their partner network. That number matters. Companies do not spend $100 million on a credential nobody will ask for. The exam validates one thing, that you can make real architecture decisions with Claude in production, not prompt party tricks trade-offs. It covers Claude Code, the Claude Agent SDK, the Claude API, and the Model Context Protocol. Anthropic calls it a 301 level exam and recommends 6 months of hands-on building before you sit it. Now the part most videos would bury, I am putting it first. Right now, the exam is exclusive to Anthropic partner organizations. If your company is in the Claude Partner Network, you can register today. Partners even get a discount on the $99. If not, you currently cannot sit this exam. That is the honest answer. So why study now? Because of one line in Anthropic's announcement. Later this year, they are introducing additional certifications for sellers, for architects, and for developers. The developer certification is coming, and this material is the foundation for all of it. The people who pass first will be the ones who were ready before registration opened. Also, any organization bringing Claude to market can apply to the partner network. Membership itself is free. Here is the shape of the thing. 60 multiple choice questions, 120 minutes, that is 2 minutes per question on average. Every question has one correct answer and 3 distractors. And these are not lazy distractors. The guide says their answers a candidate with incomplete knowledge would pick. This exam tests what not to do as much as what to do. Scoring is scaled from 100 to 1000. You pass at 720. Unanswered questions count as wrong and there is no penalty for guessing. So you answer everything. Always. It is proctored, single session, no breaks, no external resources. Results arrive within 2 business days with a section by section breakdown. Pass. And you get a CCA-F badge for LinkedIn. Fail. And remember, one attempt. That is why preparation is not optional here. Everything on the exam comes from 5 domains with fixed weights. This is straight from the official guide. Domain 1, Agentic Architecture and Orchestration, 27%, the biggest slice. Designing Agentic Loops, Coordinator and Subagent Patterns, Task Decomposition, Session State. If you only master one domain, it is this one, more than a quarter of your score. Domain 2, Tool Design and MCP Integration, 18%. Clean tool interfaces, structured error responses, and how you distribute tools across agents. Domain 3, Claude Code Configuration and Workflows, 20%. CLAUDE.md Hierarchies, Custom/Commands, Plan Mode versus Direct Execution, CI Integration. If you use Claude Code daily, this is where your experience pays off directly. Domain 4, Prompt Engineering and Structured Output, also 20%. Explicit criteria, few short examples, JSON schemas, and validation retry loops. Domain 5, context management and reliability 15%. Long-running context, escalation patterns, error propagation, and knowing what to do when the model is not sure. Smallest domain, but at 720 to pass, 15% is not something you can afford to skip. Here is the part that makes this exam different from every cloud certification I have taken. Anthropic publishes the scenarios in advance, all of them. There are 6 production scenarios, and your exam draws 4 at random. Every question hangs off one of these contexts. 1. A customer support resolution agent built on the Agent SDK with MCP tools for refunds and escalation. 2. Code generation with Claude Code /commands CLAUDE.md plan mode. 3. A multi-agent research system where a coordinator delegates to search, analysis, and synthesis subagents. 4. Developer productivity tooling over a real code base with the built-in tools. 5. Claude Code inside a CI pipeline, doing automated code review with structured feedback. 6. Structured data extraction from messy documents, validated against JSON schemas. Read those again. They are not exotic, they are the 6 systems everyone is building right now. Which means studying for this exam is not exam cramming, it is just becoming good at the actual job. Anthropic gives you 3 official resources, all free. First, the exam guide. It lists every domain, every task statement, and all 6 scenarios. It is the syllabus, and most candidates never read it properly. Second, Anthropic Academy 4 recommended courses building with the Claude API, Introduction to MCP, Claude Code in Action, and Claude 101. The Academy courses are free, and they hand out completion certificates, even today, even without partner access. Third, the practice exam. Anthropic's own advice is blunt. Do not book the real thing until you score above 900 on practice. (900), not 720, because exam day pressure eats the difference and you only get one attempt. So here is the plan for this series. 12 episodes mapped 1-to-1 against the official blueprint. Episodes 2 to 4 cover domain 1, Agentic architecture, the 27% monster. Then tool design and MCP, then Claude Code configuration, then prompting and structured output, then reliability. Episode 11 dissects all 6 scenarios with work questions. Episode 12 is pure exam strategy. No paywall, no fluff, and when something is my opinion instead of the official guide, I will say so on screen. Next episode we start where the points are, the agentic loop and the stop reasons that control it. If you are preparing for this certification, subscribe and bring your one attempt to the exam ready. See you in episode 2. Here is an agent finishing a task. It printed task complete. Looks done. The exam will show you an agent exactly like this one and ask how it should decide it is finished. If your answer involves reading that text, you just lost the question. Welcome back to the CCA exam prep course. This is episode 2. Domain 1, Agentic architecture and orchestration is 27% of your score. The biggest slice on the exam. And all of it builds on one concept, the agentic loop. By the end of this episode, you will answer a real exam style question about it. An agent is not magic. An agent is a loop. 4 steps, repeating. Step 1, you send the conversation to Claude with your tool definitions attached. Step 2, Claude answers, and you check one field on the response stop_reason. This field is how the model tells you why it stopped generating. It is the heartbeat of the loop. If stop reason says tool use, Claude is requesting a tool call. The model wants information it does not have. So step 3, your code executes the tool. Claude never runs anything itself. Your harness does. Step 4, you append the result to the conversation and send the whole thing back. The loop runs again. Claude now reasons with the new information, and when stop reason says end turn, Claude is finished. The loop exits, that is the termination signal. Not the text, not a vibe, one enum field. Here is the entire pattern in Python. 15 lines. The exam expects you to know every one of them. A while loop, inside it one API call, carrying the tools and the full message history. First thing after the response, if stop reason is end, turn, break, done. Now the detail that distractors love. Before you run any tool, you append Claude's response to the history, the entire content array, including the tool use blocks. If you only append the text and drop the tool use block, the API rejects your next request. The tool result would have nothing to point at. Then you execute each requested tool and build a tool result block for each one. Each result carries the ID of the tool use block it answers. They must match 1 to 1. Every tool use block needs exactly one result, miss one, and the request fails. And here is the part people get wrong on the exam. Tool results go back as a user message, not assistant, not system. The user role carries the tool results and all of them go back in a single message. Then the loop repeats. That is the whole machine. Why does appending matter so much? Because the API is stateless. Claude does not remember your last request. The only memory an agent has is the message history you send. So, the conversation literally accumulates the agent's experience. Question, tool call, tool result, reasoning, next tool call. When a tool fails, you do not hide it. You send the error message back as the tool result with the isError flag set to true. Claude reads the error and adapts, tries different input or a different tool, or asks the user. The guide calls this out directly. A failed tool call is information, not a crash. One more concept from task statement 1.1, and it shows up all over the scenarios. The distinction between model-driven decisions and pre-configured decision trees. In the agentic loop, Claude decides which tool to call next based on everything in the context. That is model-driven. A decision tree if refund request, then call lookup order, then call process refund is your code deciding in advance. Decision trees are predictable, but they shatter on inputs you did not anticipate. The exam scenarios are full of high ambiguity requests like billing disputes. That ambiguity is exactly what the model-driven loop is for. When a question asks where the decision logic should live, the answer is almost always in the model, not in a hard-coded sequence. The exam guide literally lists the anti-patterns it will test you on. Here they are. Anti-pattern 1. Parsing natural language to decide termination, searching the text for task complete. The hook of this episode. Never. Anti-pattern 2. Using an iteration cap as the primary stopping mechanism. A cap is fine as a safety backstop. It is wrong as the way the loop normally ends. Anti-pattern 3. Treating the presence of text as a completion signal. Claude often writes text right before calling a tool. Text means nothing about being done. One field decides stop reason. And know the other values too. Max tokens means you hit the output limit, that is truncation, not completion. Pause turn means a long server-side turn paused and you continue it by sending the response straight back. Each one of these is a distractor wearing a costume. Time to apply it. This is in the style of the real exam, scenario based, 1 correct answer, 3 traps. Your customer support agent handles refunds using the Agentic loop. How should the loop decide to stop? Option A. Stop when the response text contains a completion phrase such as your refund is processed. Option B. Stop after 10 iterations to guarantee termination. Option C. Stop when stop reason equals end turn with an iteration cap as a safety backstop. Option D. Stop when the response contains a text block instead of a tool call. Walk it like the exam wants you to. A is anti-pattern 1, parsing text, gone. B is anti-pattern 2, the cap as the primary mechanism, gone. D is anti-pattern 3, text as a completion signal, and remember Claude writes text before tool calls, gone. C. Stop reason and turn with the cap demoted to a backstop. That phrasing primary signal plus safety backstop is exactly how the correct answer reads on this exam. Lock in 4 things from this episode. The loop, send, check, stop reason, execute, append, repeat. Tool results. User message, matching IDs, 1 result per call, errors included with the flag set. Decisions live in the model, not in hard-coded trees. And termination is stop, reason, and turn, never the text. Next episode, multi-agent orchestration, coordinators, subagents, and why they share nothing by default. Subscribe if this is useful. There are 10 more episodes coming, and they go deeper every week. Here is one agent trying to do everything. Search the web, read 10 documents, synthesize the findings, write the report. By the time it reaches the report, its context is a swamp and it has forgotten what it found at the start. The exam has a scenario built around exactly this problem, and the answer is not a bigger agent. Welcome back to the CCA exam prep course, episode 3. Last time, the single agentic loop. Today, what happens when one loop is not enough, coordinators and subagents. This is still domain 1, the 27% monster, and it is the heart of exam scenario 3, the multi-agent research system. So why not just give one agent all the tools and let it run? 2 reasons the exam cares about. First, context. Every document the agent reads, every search result piles into one window. Late in the task, the important early findings get buried or pushed out. Second, focus. An agent juggling 4 different jobs, does each one worse than 4 agents each doing one job? Well, the fix is decomposition. One coordinator splits the work and hands each piece to a specialized subagent with its own fresh context. Search the web, analyze the documents, synthesize the findings, generate the report. 4 focused agents instead of one overloaded one. The architecture has a name. The exam uses hub and spoke. The coordinator is the hub. Every subagent is a spoke. And here is the rule that trips people up. Subagents do not talk to each other. All communication routes through the coordinator. The coordinator delegates. The subagent returns its result to the coordinator, and the coordinator decides what happens next. That central routing is not a limitation, it is the point. Because everything flows through one place, you get observability, consistent error handling, and controlled information flow. The coordinator owns task decomposition, deciding which subagents to invoke and aggregating their results into one answer. If a subagent fails, the coordinator handles it, not some tangle of agents blaming each other. Now the single most tested idea in this whole domain, write it on your hand. A subagent does not inherit the coordinator's context. When the coordinator spawns a subagent, that subagent starts with a blank slate. It does not see the conversation history. It does not see what other subagents found. It does not share memory between invocations. So if your coordinator tells a synthesis subagent, synthesize the findings, the subagent asks, what findings? It has none. Everything the subagent needs must be put directly into its prompt. If the synthesis agent needs the web search results and the document analysis, the coordinator pastes those results into the synthesis agent's prompt explicitly. Every time on the exam, any answer that assumes a subagent can see the parent's context is wrong. Every time, how does a coordinator actually create a subagent? With the task tool. The task tool is the mechanism for spawning subagents in the agent SDK. And here is a detail the exam tests directly. For a coordinator to invoke subagents, its allowed tools must include task. No task in allowed tools, no subagents. A coordinator without it is just a normal agent that cannot delegate. Each subagent type is configured with an agent definition, a description, its own system prompt, and its own tool restrictions. Your search agent gets web tools. Your synthesis agent gets none. It only reasons over what you hand it. You restrict each subagent to exactly what its job needs, and to run subagents in parallel, the coordinator emits multiple task calls in a single response, not one per turn, spread across turns. Multiple task calls, one response, and they run side by side. That is how a research system searches 3 sources at once instead of one after another. Since you are pasting findings into prompts, how you structure that matters. 2 skills from the guide. First, pass complete findings. Not summaries the subagent can't expand. The synthesis agent gets the actual search results and the actual document analysis, the whole thing. Second, use structured data to separate the content from its metadata. Keep the source URL, the document name, the page number alongside the content in a structured format. Why attribution? A research report has to cite where each fact came from. If you flatten everything into one blob of text, the citations are gone by the time you reach the report agent. Structured context in cited report out. Last piece, how to design the coordinator's own prompt. 3 principles, all tested. 1. Specify research goals and quality criteria, not step-by-step procedures. If you script every step, the subagents can't adapt when reality differs from your script. Give them the goal and the bar for good enough and let them adapt. 2. Have the coordinator decide which subagents to invoke based on the query, not blindly run the full pipeline every time. A simple factual question does not need the document analysis agent. A good coordinator skips it. 3. Build an iterative refinement loop. The coordinator evaluates the synthesis for gaps, redelegates to search and analysis with targeted queries, and reruns synthesis until coverage is sufficient. And watch the failure mode. The guide names, if the coordinator decomposes too narrowly, it misses whole parts of a broad topic. Coverage is the coordinator's job. One more tool in this domain, fork-based sessions. When you want to explore divergent approaches from the same starting point, you fork the session branch from a shared analysis baseline into independent explorations. Same foundation, different directions, run independently. Useful when there's more than one reasonable way forward and you want to try several without them interfering. Apply it. Scenario 3 style, 1 correct answer, 3 traps. You are building the multi-agent research system. A coordinator delegates to a search subagent, then needs the synthesis subagent to combine the findings. How should the coordinator pass the search results to synthesis? Option A. Store the results in shared memory. The synthesis subagent will read them automatically. Option B. Include the complete search results with source URLs directly in the synthesis subagent's prompt. Option C. Have the search subagent call the synthesis subagent directly with its findings. Option D. Tell the synthesis subagent to rerun the same searches itself. Walk it. Assumes shared memory between subagents. They inherit, nothing gone. C is subagent to subagent communication. Everything routes through the coordinator, gone. D throws away the work the search agent already did and doubles the cost, gone. B. Complete findings with source URLs for attribution placed directly in the prompt. That is the hub and spoke rule and the context passing rule in one answer. Lock in 4 things. Hub and spoke subagents never talk to each other, everything routes through the coordinator. Subagents inherit nothing, put every finding they need directly in the prompt, structured with attribution. Spawn with the task tool. Allowed tools must include task and run them in parallel with multiple task calls in one response. Design the coordinator with goals and quality criteria, dynamic selection, and a refinement loop, not a rigid script. Next episode, hooks, enforcement, and session state. What to do when a prompt instruction isn't a strong enough guarantee. Subscribe, and I'll see you in episode 4. You wrote it right there in the system prompt. Never issue a refund over $500. And the agent just refunded $4,200. It did not malfunction. It is a language model. A prompt is a strong suggestion, not a guarantee. This episode is about the difference between asking an agent to follow a rule and making it impossible to break. Welcome back to the CCA exam prep course, episode 4. Hooks, enforcement, and session state. Still domain 1, and this is where a lot of people lose points because the exam keeps asking prompt or guarantee. Here is the mental model the whole domain runs on. Anything you put in a prompt is probabilistic. The model usually follows it. Usually is not always. There is a non-zero failure rate. Anything you enforce in code is deterministic. It happens every time, or it is blocked every time, no exceptions. So the exam question underneath every scenario is, does this rule need a guarantee? A friendly tone, a prompt is fine. If it slips once, nobody gets hurt. Verify identity before a financial operation, that needs a guarantee. A 1 in 1,000 slip is a security incident. When deterministic compliance is required, prompt instructions alone are the wrong tool. You move that rule into code. The first enforcement pattern, the prerequisite gate. A gate blocks a downstream tool call until a prerequisite step has actually completed. Take the customer support scenario. The rule is never process a refund until you have verified the customer. So you block process refund programmatically until get container has returned a verified customer ID. Not please verify first in the prompt, blocked in code. If the verified ID is not there, the refund call cannot fire. The agent can still reason, still plan, still call other tools, but that one door stays locked until its prerequisite is met. That is the difference between an instruction and a gate. Gates are one case of a more general mechanism, hooks. A hook is code that sits on the wire between the agent and its tools and runs automatically the Agent SDK gives you two you need to know. First, pre-tool use. It fires before a tool call executes and it can block that call. The agent tries to refund $4,200. The pre-tool use hook checks the amount, returns a permission decision of deny, and the refund never happens. Then it redirects hand this to a human. The policy is enforced in code, not hoped for in a prompt. And the deny carries a reason, which goes back to the agent so it understands why and can take the alternative path. This is the exam's favorite distinction: hooks for deterministic guarantees versus prompts for probabilistic compliance. When the business rule must hold, you reach for the hook. The second hook is post-tool use. It fires after tool returns and it can transform the result before the model ever sees it. The classic use: normalization. Your agent talks to several MCP tools and they disagree on formats. One returns a Unix timestamp, one returns ISO 8601, one returns a numeric status code. A post-tool use hook rewrites all of them into one consistent shape using updated tool output to replace what the agent receives. Now the model reasons over clean, uniform data instead of wasting tokens and making mistakes untangling three formats. Block bad calls on the way out with pre-tool use. Clean messy results on the way back with post-tool use. Enforcement also covers what happens when the agent hits its limit and escalates to a human. Here is the trap. The human agent does not have the conversation transcript. They are picking this up cold. So the escalation cannot just say, "Customer is upset, please help." It has to compile a structured handoff summary: the customer ID, the root cause, the refund amount, and the recommended action. Everything the human needs to act in one packet because they did not see anything that came before. A good escalation is a clean briefing, not a shrug. One more design decision the exam tests: how to break a big task into steps. Two patterns. Prompt chaining is a fixed sequential pipeline. Step 1, then step 2, then step 3, known in advance. Good when the work is predictable. Dynamic decomposition builds the plan as it goes, generating subtasks based on what it discovers at each step. Good for open-ended investigation. The guide's example is a code review, which is exam scenario 5. You do not review a whole code base in one giant pass. Attention gets diluted and the model misses things. Instead, a per file local pass that analyzes each file on its own, then a separate cross-file integration pass that catches what spans files. Predictable multi-aspect work, prompt chaining, open-ended exploration like adding tests to a legacy code base, map the structure first, then a prioritized plan that adapts. Last piece, managing state across sessions. Tasks 1.7. 3 things to know. 1. Resume. You continue a specific prior conversation by its session ID resume in the Agent SDK or the resume flag in Claude Code. 2. Fork. We met this last episode. Fork session branches from a shared baseline into independent explorations, each with its own new session. 3. And this is the tested judgment call. When you resume a session after the underlying files have changed, the agent is holding stale tool results. It thinks the code still looks the way it did before. 2 rules. If you do resume, you must tell the agent what changed since. And often, starting a new session with a clean, structured summary is more reliable than resuming with stale results dragging along. Fresh summary beats stale state. Apply it. Scenario 1, the customer support agent. Company policy: Refunds over $500 must never be issued automatically. They go to a human. How do you enforce this? Option A. Add a clear, emphatic instruction to the system prompt. Never auto-issue refunds over $500. Option B. A pre-tool use hook that denies any process refund over $500 and redirects to human escalation. Option C. Ask the agent to double-check the amount before calling process refund. Option D. A post-tool use hook that flags large refunds after they are issued. Walk it. A is a prompt probabilistic. Most of the time is not good enough for money. Gone. C is also just a prompt instruction dressed up as a check. Same non-zero failure rate. Gone. D acts after the refund already went out. The money is gone. Flagging it is too late. Gone. B. A pre-tool use hook that denies the call before it executes and redirects, deterministic before the fact. That is the guarantee the policy demands. Lock in 4 things. Prompts are probabilistic. Code is deterministic. When a rule must hold, enforce it in code. Prerequisite gates block a downstream call until its prerequisite has actually completed. Pre-tool use blocks or redirects calls before they run. Post-tool use transforms and normalizes results after escalate with a structured handoff, and prefer a fresh summary over assuming with stale state. Next episode, we leave domain 1 and start domain 2. Tool design and MCP integration 18%, and the place most people's tool schemas quietly cost them points. Subscribe, and I'll see you in episode 5. Your agent has the right tool for the job, it just called the wrong one. Not because the model is dumb, because you gave it 3 tools named almost the same and a description that said code gets data. The model never sees your code, it sees a name, a description, and a schema. That is the entire interface. If that interface is ambiguous, the model guesses, and sometimes it guesses wrong. Welcome back to the CCA exam prep course, episode 5. We just finished domain 1. Today we start domain 2, tool design and MCP integration, 18% of the exam. One honest note up front. The public exam guide spells out domain 1 in detail. For domain 2, I'm mapping straight from Anthropic's own tool use and MCP documentation. I'll keep it to what the docs actually say. Start with the single highest leverage thing in this whole domain, the tool description. Anthropic's docs say it plainly. The description is by far the most important factor in tool performance. Not the model, not the prompt, the description. Here is the test. A poor description says, gets the stock price. A good one says what the tool does, when to use it and when not to, what every parameter means, and any limitation like this data is delayed 15 minutes. The guidance is to aim for at least 3 or 4 sentences per tool, more if it's complex. Write it for someone who has never seen your code, because that is exactly the model situation. A vague tool description is the number one reason agents call the wrong tool or fill in the wrong argument. Fix the description, and a surprising number of the model is bad at tools problems just disappear. Next, the schema and the name. A tool definition has 3 required parts: a name, a description, and an input schema written as JSON schema. The schema is not just types. Describe each property inside the schema too, what it's for, what format it expects. The model reads those descriptions the same way it reads the tools. Two design rules the exam leans on. First, consolidate. Instead of a separate tool for every tiny action, create PR review PR. Merge PR, group them into one tool with an action parameter. Fewer, more capable tools mean less for the model to disambiguate. The failure mode from the intro, 3 tools that all sound the same. That is what consolidation prevents. Second, namespace. When your tools span several services, prefix the names GitHub_list, PRS, Slack_send message. Now selection is unambiguous. The model knows which world each tool lives in. And design what the tool returns. Hand back only high signal information with stable identifiers, a slug or an ID, not opaque internal junk that wastes the context window. Now the part most people get wrong. What happens when a tool fails? A tool result can carry an is_error flag set to true with a message. The temptation is to return the string failed and move on. That tells the model nothing, it can't recover, so it gives up or loops. Instead, write an instructive error. Not failed, say rate limit exceeded, retry after 60 seconds. Now the model has what it needs to adapt. Wait, then retry. The error becomes a recovery instruction, not a dead end. This is the exam's framing of robustness. A well-designed tool fails informatively. The agent reasons over the error message the same way it reasons over a successful result. One more parameter to know. By default, the model can call several tools in parallel. Set disable parallel tool used to true, and it makes at most one tool call per turn, which you want when later steps depend on earlier results. That covers designing your own tools. The other half of this domain is MCP, the Model Context Protocol. One sentence, MCP is an open standard for connecting AI applications to external systems, tools, data, and workflows. The docs call it a USB-C port for AII, one standard plug instead of a custom integration for every service. The architecture has 3 roles, and the exam tests that you know which is which. The host is the AI application, Claude Code, Claude Desktop, your agent. The host runs one client for each server it connects to. And a server is the program that exposes capabilities, a GitHub server, a database server, a file system server. The rule to remember, one client, one server, one dedicated connection. The host coordinates them all. A server can run locally on your machine or remotely. The word server is about the role, not the location. So what does the server actually expose? 3 primitives. This is a classic exam recall question. 1. Tools. Executable functions the agent can invoke to do something. Call an API, query a database, write a file. Actions. 2. Resources. Data. The server makes available as context, file contents, records, a document. Resources are things the model reads, not actions it takes. 3. Prompts. Reusable templates the server offers, a pre-built prompt or workflow. The user or app can pull in. Tools do, resources inform, prompts template. If you remember nothing else from this section, remember those 3. How does the client actually talk to the server? 2 transports, and the choice is mostly local versus remote. First, standard input-output (STDO). The server runs as a local process on your machine. The client talks to it over standard in and standard out. No network, lowest overhead. This is the default for local servers. Second, HTTP, streamable HTTP, sometimes shown as SSE. The server runs somewhere else and you reach it over the network with normal HTTP authentication, bearer tokens, API keys, headers. This is how you connect to a remote hosted server. Same protocol, same 3 primitives underneath. The transport just changes how the bytes get there. Last piece, how this shows up in Claude Code and the Agent SDK, because the exam asks the practical version. You register a server in a config file .mcp.json or with the command claudemcp add. Once it's connected, its tools appear to the agent with a predictable naming convention. The name is MCP, _ the server name, _ the tool name. So a list PR's tool on a GitHub server becomes MCP, GitHub, list PRs. When you see that _ shape in an answer, you're looking at an MCP tool. And you don't have to expose everything. You scope which tools an agent or sub-agent may use with an allowed tools list using those same full tool names. This connects straight back to domain 1. Least privilege is a design decision, not an afterthought. Let's apply it. Scenario 4. A developer productivity agent wired over MCP to GitHub, Jira, and Slack. The problem, it keeps calling the wrong tool, posting to Slack when it should comment on a pull request. What is the right fix? Option A. Lower the temperature so the model behaves more deterministically. Option B. Write detailed, unambiguous tool descriptions, what each does and when to use it, and namespace the overlapping tools by service. Option C. Add a paragraph to the system prompt listing which tool to use in which situation. Option D. Give the agent more tools so it always has an exact match for any request. Walk it. A temperature changes phrasing, not tool comprehension. Wrong tool, wrong lever, gone. C. A system prompt list is a prompt, probabilistic, and it rots the moment you add a tool. It treats the symptom, not the ambiguous interface. Gone. More tools is more to confuse. It makes selection harder, not easier. The opposite of consolidation. Gone. B. Fix the descriptions and namespace the tools. You are repairing the actual interface the model selects from. Deterministic improvement at the source. That's the answer. Lock in 4 things. The model only knows a tool by its name, description, and schema. The description is the highest leverage thing you can fix. Consolidate overlapping tools, namespace across services, and return only high signal data. Make failures informative. An is Azure result with an instructive message lets the agent recover instead of giving up. MCP is one open standard. Host, client, server, 3 primitives, tools, resources, and prompts. 2 transports, STDO local and HTTP remote, tool surface as MCP server tool. That's domain 2. Next episode we move into domain 3, Claude Code configuration, CLAUDE.md hierarchies, / commands and path rules. Subscribe and I'll see you in episode 6. Every session you explain the same things. Use PAPM, not NPM. Tests go here. Don't touch the infra folder. The model has no memory between sessions. So you repeat yourself forever, or you write it down once in a place Claude Code reads automatically. That is what configuration is. And the exam doesn't test whether you can write a config file. It tests whether you know, for any given rule, 2 things: what scope it belongs to and whether it's guidance or a guarantee. Welcome back to the CCA exam prep course, episode 6. We are into domain 3 now, Claude Code configuration and workflows, 20% of the exam. One note, same as last time, the public exam guide details domain 1 only. Domain 3 I'm mapping from the Claude Code docs, and I'll keep it to what they actually say. This episode is the configuration half, memory, commands and permissions. Start with memory, the CLRU.md file. This is where your written down instructions live, and there isn't one file, there is a hierarchy. 4 layers. At the top, enterprise or managed memory set by an organization, and it can't be turned off. Then user memory in your home Claude folder, that applies to every project you work on. Then project memory, a CLAUDE.md checked into the repo, shared with your whole team, and local memory, CLAUDE.local.md git ignored for your personal tweaks on this one project. Here is the part people get wrong on the exam. These layers do not override each other. They compose. Every applicable file gets concatenated into context together, the organization's rules, your personal rules, and the project's rules all at once. And Claude Code finds them by walking up the directory tree from where you are, memory files deeper in the tree, say inside one package of a monorepo, load on demand when Claude actually works in that folder. So the instructions match where you were working. 2 practical rules for the memory file itself. First, you can import other files with an @ sign and a path at docs/conventions.md pulls that file in. It works with the tilde for your home directory too, and it nests a few levels deep. So you keep one short CLAUDE.md that pulls in focus pieces instead of one giant wall of text. Second, and this is an architect level point, every line of memory costs context on every single session forever. A bloated CLAUDE.md quietly taxes every conversation. Keep it tight, the instructions that actually change behavior, not a novel. Lean memory is a design decision, not laziness. Now the axis, the whole domain turns on, and if you watched episode 4 you already know it. CLAUDE.md is guidance. It's delivered to the model as instructions, and the model usually follows them. Usually because it's still a prompt, and a prompt is probabilistic. So if a rule absolutely must hold, never delete this folder, never call this API CLAUDE.md is the wrong place. That is a guarantee, and guarantees live in permissions which the client enforces in code no matter what the model decides. Prefer PMPM guidance, put it in memory. Never run a destructive command on the infra folder. Guarantee, put it in a permission rule. Same question as the refund from episode 4. Does this rule need a guarantee? Configuration is just that question applied to your whole setup. Next tool in the box, /commands. A /command is a reusable prompt saved as a markdown file. Drop a file at .claude/command/review.md and you get a /review command. The file name becomes the command name. Scope shows up again here. Commands in the project's .claude folder are checked in and shared with the team. Commands in your home Claude folder are personal across all your projects. Same project versus user split as memory. Inside the command you can take arguments, $arguments for everything the user typed, or $1, $2 for positional ones. You can run a shell command with a leading exclamation mark and inject its output and pull in a file with @path. And the front matter can pre-approve specific tools, give an argument hint, a description, and even pin a model. The exam framing: reach for a /command. When you have a repeatable workflow, you keep retyping. Memory is what Claude always knows. A command is something you invoke on demand. Permissions: this is the enforcement layer, the guarantees. It lives in a settings.json file and it has 3 lists. Allow these tools and commands run without asking. Ask prompt me first. Deny never full stop. The rules are patterns, git ignore style. Allow bash npm run test : any test script, no prompt. Allow read on your source folder. Deny read on .env files, so secrets never enter context. Deny the destructive commands outright. And the rule to memorize: when allow and deny disagree, deny always wins. That is what makes it safe to share a permissive allow list. Your deny rules still hold the line. This is least privilege, and on the exam, least privilege is always the right instinct. Settings files stack in a precedence order, and the exam likes to test which one wins. Top to bottom, enterprise managed policy beats everything and can't be overridden. Then command line flags for this session. Then your local project settings.local.json get ignored. Then the shared project settings checked into the repo. Then your user settings at the bottom applying everywhere. They merge rather than replace, but where they conflict, the higher layer wins, and a deny anywhere in the stack still wins over any allow. Organization safety rules can't be configured away by a project. That is the governance guarantee. Pull it together with the question we opened on scope. For any rule, you are really deciding who should have it. Should the whole team get it? Consistently check it into the repo project CLAUDE.md, project settings, project commands. That's how you make a team's Claude Code behave the same for everyone. Is it just your personal preference on this project? The local get ignored files across all your projects, your user files, and anything the organization must enforce regardless, managed policy at the top. Get scope wrong and config silently fails. A rule you put in your personal file never reaches your teammate and you both think you are right. Let's apply it. Scenario 2, a team using Claude Code to generate code. They want two things to hold for every developer. Claude must know the project's conventions, and it must never modify the production infra folder. What's the right setup? Option A. Each developer adds the conventions and the restriction to their own home folder user memory. Option B. Commit a project CLRU.md with the conventions plus a project settings.json with a deny rule on the infra folder. Option C. Put everything in CLAUDE.local.md so it's local to the project. Option D. Ask every developer to paste the conventions and the restriction at the start of each session. Walk it. A user memory is personal. It doesn't travel with the repo and it drifts per developer. Not shared. Gone. CLAUDE.local.md is get ignored. It never reaches teammates, the whole team requirement fails. Gone. Manual pasting doesn't persist, and never touch infra as a typed instruction is still guidance, not a guarantee. Gone. P. Project CLRU.md is checked in, so everyone gets the conventions, that's the guidance part, and a committed deny rule enforces the infra restriction in code, that's the guarantee. Right scope, right mechanism. That's the answer. Lock in 4 things. Memory is a hierarchy, managed, user, project, local, and the layers compose into context. They don't override. Ask 2 questions of every rule. What scope does it belong to, and is it guidance or a guarantee? CLRU.md and / commands are guidance. Permissions are enforcement where deny always wins and least privilege is the default instinct. Scope decides, check it into the repo for the team, keep it in get ignored local files for yourself, and let manage policy enforce what the organization requires. Next episode finishes Domain 3, plan mode versus direct execution, and running Claude Code headless in CI. Subscribe and I'll see you in episode 7. 2 ways this goes wrong. You ask for a one-line fix and Claude rewrites 30 files, touches a migration and bumps a dependency you never mentioned. Too much freedom, nobody checked. Or the opposite, you sit there approving every single edit, 1 yes at a time, until you are just a very slow keyboard, too little freedom and you automated nothing. Between those 2 failures is a dial. How much do you let Claude Code do before a human looks? Episode 6 was configuration, what Claude knows. This episode is the other half of Domain 3, workflow, how much it's allowed to act. Welcome back to the CCA exam prep course, episode 7. Same note as last time, the public exam guide spells out Domain 1 only. So domain 3 I'm mapping from the Claude Code docs, and I'll keep it to what they actually say. Here is the thread for the whole episode. The dial is the same whether a human is in the room or not. When you are there, plan mode is the brake. When you are not in CI, the brake has to be installed ahead of time. Same decision, 2 settings. Start interactive view in the chair. Claude Code runs in a permission mode, and the mode is just where the autonomy dial is set. At one end, plan mode, Claude investigates and proposes, but changes nothing until you say go. Then default mode, it asks you before each sensitive action. Then accept edits mode, it makes file edits without stopping, and you review them after with git diff. And further along, the hands-off settings for long autonomous runs. You cycle these leave by pressing Shift Tab default to accept edits to plan, and the mode you're in decides how often Claude stops to check with you. So the exam's framing isn't which mode is best. It's for this task, how much should Claude do before you look, plan first, or execute directly. Everything in this half of the domain is that one question. Look closely at plan mode because it's the safety tool the exam loves. In plan mode, Claude reads your files and runs read-only shell commands to understand the code base, but it does not edit your source. Nothing is written. When it's worked out an approach, it stops and shows you a plan, the actual steps it intends to take, and asks for approval before touching anything. You can approve and let it run, approve and review each edit, or send it back to refine the plan first. 2 ways to enter it. Interactively, Shift Tab into it, or from the command line, start the session with the permission mode plan flag. So it opens straight into planning. One subtlety worth a point on the exam, plan mode is read only, but it is not a permission bypass. The normal rules still apply. If something needs approval, you're still asked. Plan mode narrows what Claude does, it never widens it. So when do you reach for plan mode versus just executing? This is judgment, and the exam tests the judgment, not a memorized rule. Reach for plan first when the blast radius is large, a refactor across many files, when you don't know the codebase yet and want to see the approach before it runs, when the request is ambiguous, or when a mistake is expensive to undo. You're buying a checkpoint before the irreversible part. Execute directly when the change is small and well scoped. You know the area, and it's cheap to revert a typo, a single function, a test you can rerun. Forcing a plan for a one-liner is just the slow keyboard failure from the open match, the break to the risk. Now take the human out of the chair entirely. That's the other thing this domain test. Claude Code running headless in automation. The key is the print flag -p. You give Claude one prompt on the command line. It does the work, prints the result, and exits. No conversation, no waiting on you. That's what lets it live inside a script or a pipeline. And because something downstream has to read the result, you choose an output format, plain text for a human, JSON for one structured payload your script can parse, or streaming JSON when you want the events line by line as they happen. The other half of automation is the exit code. Success exits 0 and error exits 1. So a CI job can pass or fail the build on what Claude found. That turns Claude Code from a chat tool into a step in a pipeline. The most common place this shows up is GitHub. Anthropic ships an official action, Claude Code action, that drops Claude Code into your repository's workflows. There are 2 ways to wire it. Interactive. A teammate writes at Claude in a pull request or an issue comment, and the action wakes up, does the task, and replies right there in the thread. Or automated, no mention at all. You give the workflow a fixed prompt and a trigger, like every pull request or a nightly schedule. The setup is mostly one secret, your API key, stored in the repository's secrets, never in the file. From there, the documented patterns are what you'd guess. Triage incoming issues, review every pull request, run, schedule cleanup jobs, or enforce a custom check the build depends on. For the exam, the shape to hold is this. At Claude mentions for on-demand help, a prompt plus trigger for fully automated runs, and the API key kept in secrets. Here is where episode 6 pays off, and it's the heart of the exam CI questions. In automation, there is no human to answer a permission prompt, so every approval has to be decided in advance. That changes how the modes behave. An ask rule, prompt me first, is useless headless. There's no one to ask, so it just blocks. What you want instead is an explicit allow list of exactly the tools the job needs, and a mode that refuses anything outside it rather than pausing to ask. 2 anchors to remember. The safe default for a pipeline is least privilege, list the specific tools the job is allowed, and run a mode that denies everything else automatically. Your deny rules from settings still apply on top. Same as always, deny still wins, even with no human watching. The dangerous option is bypassing permissions entirely, letting Claude do anything. There's exactly one place that belongs: an isolated, throwaway environment, a fresh container that can't hurt anything real, never against your production repo. And cap the run, limit the number of turns and the budget, so an automated loop can't spin forever. Least privilege isn't just a config tip here. In CI, it's the whole safety story. Let's apply it. Scenario 5. A team wants Claude Code to review every pull request automatically with no human kicking it off. The job must run on each PR, comment its findings, and never modify the repository or reach anything outside it. What's the right setup? Option A. Add at Claude as a comment on each pull request manually, so a teammate triggers the review. Option B. Run the official action on the pull request trigger with bypass permissions, so nothing blocks the job. Option C. Run it headless with the print flag on the pull request trigger, and allow list limited to read and comment tools, a no ask mode so anything else is denied, and the API key in secrets. Option D. Run it headless but in plan mode, so it can't edit anything. Walk it. A manual at Claude needs a human every time. The requirement was no human kicking it off. That's the workflow we are trying to replace. Gone. B. Bypass permissions against the real repo is exactly the thing you never do. It can modify or reach anything, and the job is supposed to be read and comment only. Wrong and unsafe. Gone. D. Plan mode stops edits. True, but it's built for an interactive approval you're not there to give, and it doesn't grant the comment posting the job needs. Wrong tool for headless. Gone. C. Triggered on each PR, no human, a tight allow list of just read and comment, a mode that denies everything else instead of hanging on a prompt, key in secrets. Right, autonomy, pre-installed safely. That's the answer. Lock in 4 things. 1 dial, 1 question. How much should Claude do before a human checks? Plan mode is the break when you are in the chair. Pick it for large blast radius, unfamiliar code, or anything hard to undo, and execute directly for small reversible changes. Plan mode is read only. It reads and proposes, never edits until you approve, and it's not a permission bypass. The normal rules still apply. Headless is the print flag -P1 prompt, structured output, and exit code your build can gate on, and GitHub's official action runs it on at Claude mentions or on a trigger with the API key in secrets. And the one that decides the CI questions with no human to approve, pre-install the break, least privilege, an explicit allow list, deny still wins, bypass only inside a throwaway container, and cap the turns. That closes domain 3. Next episode we move into domain 4, prompt engineering, explicit success criteria, few short examples, the things that make Claude's output reliable instead of lucky. Subscribe and I'll see you in episode 8. Here is the same prompt run 3 times. 3 completely different answers, 1 too short, 1 a wall of text, 1 in the wrong tone. The prompt wasn't wrong, it was vague. And a vague prompt gets you a lucky output, not a reliable one. Think of Claude as a brilliant new colleague who's sharp but has none of your context. If your instructions would confuse a teammate with no background, they'll confuse Claude too. That's the whole game of this domain, making the implicit explicit. Welcome back to the CCA exam prep course. Episode 8, we are into domain 4 now. Prompt engineering and structured output, another 20% of the exam. This episode is the prompting half. Same honesty note as always. The public exam guide spells out domain 1 only. So domain 4 I'm mapping from Anthropic's prompt engineering docs, and I'll keep it to what they actually say, the stable techniques in the order the docs recommend reaching for them. Technique 1 and the foundation under everything else, be clear and direct. Claude responds well to explicit instructions and follows them literally, so the more precisely you say what you want, the better the result. That means spelling out your success criteria. What does a good answer actually look like? State the output format you expect. When order or completeness matters, give the steps as a numbered list. And tell Claude why the task matters. Context improves the output. It doesn't waste tokens. Anthropic's golden rule for this is the colleague test. Show your prompt to someone with minimal context on the task and ask them to follow it. If they'd hesitate, so will Claude. And if you want effort beyond the obvious, ask for it explicitly. Don't rely on the model to read your mind. Clear and direct is cheap, and it fixes more problems than any other single move. Technique 2, and it's the highest leverage one on the list. Examples: few shot prompting, also called multi-shot. Instead of describing the output you want, you show it a handful of input-output pairs right there in the prompt. The docs are specific here, 3 to 5 examples for best results. Make them relevant, they should mirror your real cases, and make them diverse. Cover the edge cases and vary them enough that Claude doesn't latch onto a pattern you didn't intend. Examples are the most reliable way to pin down format, tone, and structure. Far more reliable than adjectives like professional or concise. And there is a structural detail that matters. Wrap each one in example tags and group them in an examples block, so Claude can tell your demonstrations apart from your instructions. If you only do 2 things from this episode, it's be explicit and show examples. That tag idea generalizes into technique 3. Structure your prompt with XML tags. When a prompt mixes instructions, background context, the data to work on, and examples all together, the boundaries blur and Claude can misread where one ends and the next begins. Wrapping each part in its own tag, instructions, context, document, example, removes the ambiguity. Use clear, consistent names and nest them. When the content has a hierarchy like a documents block holding several document entries, it's a small habit that pays off most exactly when prompts get long and complex. Technique 4. For genuinely hard problems, let Claude reason before it answers. Asking the model to think step by step, to work through the logic before committing, measurably improves accuracy on multi-step reasoning, complex code, and long agent loops. One terminology update. So you're current on today's models. This is adaptive thinking. The model decides how much to think based on the task, and you tune the depth with an effort setting rather than the old manual token budget. The principle the exam cares about is unchanged. Reasoning room helps on hard tasks and it's overkill on easy ones. Technique 5. Give Claude a role in the system prompt. Telling the model who it is: a senior support lead, a meticulous code reviewer, A careful financial analyst focuses its behavior and tone for your use case. The docs note even a single sentence makes a real difference. The role sets the lens, your instructions and examples fill in the detail. For the exam, remember the split. Persistent identity and behavior go in the system prompt. The specific task goes in your message. One more that trips people up on current models, and it's worth its own beat. Today's Claude follows instructions literally, and it does not silently guess your intent. The classic example from the docs: ask, can you suggest some changes? And you'll get suggestions, not edits. Even if you wanted the work done, say make these changes and it acts. Same with scope. If a rule should apply broadly, say so, because the model won't quietly generalize a narrow instruction. The lesson ties the whole episode together. Precision isn't politeness, it's how you get the behavior you actually want. Let's apply it. Scenario 1. A team is building a customer support agent on Claude. It has to classify every ticket into a fixed set of categories and reply in the company's tone, but it keeps drifting. Inconsistent categories, replies that sound off-brand. What's the best fix? Option A. Make the prompt longer and more forceful. Add very important, be consistent, and repeat the rules 3 times. Option B. Give the agent a clear role and the exact category list, state the output format, and add 3 to 5 diverse example tickets, each with its correct category and an in-tone reply in example tags. Option C. Raise the temperature so the replies are more creative. Option D. Switch to a bigger model and let it infer the categories and tone from each ticket on its own. Walk it. Emphasis and repetition aren't a technique. Be consistent in capital letters doesn't define what consistent means. Vague, just louder, gone. C. Higher temperature increases variation. It makes the exact drift they are complaining about worse, not better. Wrong direction, gone. D. A bigger model still has to infer the categories and the tone. An inference from a vague prompt is the whole problem. You'd be paying more to stay unreliable. Gone. B. An explicit role and category list and format are the success criteria. The diverse examples in tags show the exact shape, clear and direct. Plus few shot the 2 highest leverage techniques aimed straight at the problem. That's the answer. Lock in 4 things. A prompt is a spec, vague spec, lucky output. Reliability comes from making the implicit explicit, and the colleague test is your check. If a teammate would be confused, so is Claude. Reach for the techniques in order: clear and direct first, then context, then examples, then XML structure, then a role. Cheap, high leverage moves before exotic ones. Examples 3 to 5. Relevant and diverse in tags are the single most reliable way to steer the output. For hard problems, let Claude reason before answering. On current models, that's adaptive thinking, tuned by effort. And current models take you literally, say make these changes. Not could you suggest, state the scope, because they won't silently generalize. Precision is how you get the behavior you want. Next episode is the other half of Domain 4, Structured Output, getting reliable JSON with schemas, validating it, and the retry loop when the model gets it wrong. Subscribe and I'll see you in episode 9. You ask the model for an invoice total and a due date, and it answers in a nice sentence. So you write a little parser, grab the dollar amount, grab the date, it works, you ship it. Then one day the model phrases it slightly differently and your parser returns nothing. You're scraping prose with regular expressions and prose changes. That's the fragile seam this whole half of the domain is about closing. Welcome back to the CCA exam prep course, episode 9, the second half of Domain 4, Structured Output. Same honesty note, The public exam guide details domain 1 only. So this is mapped from Anthropic's tool use and structured output docs kept to what they actually say. The whole idea in one line. Stop parsing what the model says and start making it fill in a contract you defined. A shape you can read directly every time. The canonical mechanism is tool use, the same feature that lets Claude call functions. You define a tool, and the important part is its input schema, a JSON schema describing the exact fields you want back. When you send that, Claude doesn't reply in prose. It returns a tool use block, and that block's input field is a structured object that already matches your schema. You read it straight into your code. No regex, no guessing where the number is. The schema you ask for is the shape you get. That's the mental flip. The prompt used to be a request you hope the model answered well. Now the schema is a contract both sides agree on. You specify the fields, Claude fills them. For the exam, when a scenario says extract data or return structured output, tool use with an input schema is the default right answer. But a tool is optional by default. Claude decides whether to call it. For reliable extraction, you don't want maybe. You force it with the tool choice parameter. Set tool choice to type tool with your tool's name, and Claude must call that exact tool every time, so you always get the structured shape, never a chatty paragraph. There is also any, which means it must use some tool, and auto, the default, where it decides to guarantee one specific structured output, name the tool. Two things people reach for that you should skip: prefilling the reply with an open brace to trick it into JSON. That's a deprecated pattern on current models. Don't teach it to your codebase. And Claude has no OpenAI style JSON mode switch. The documented path is the schema attached through tool use. The schema isn't paperwork, it's where you do the real work, because every constraint you add shrinks the space for the model to get it wrong. Give every field a type. List the must-have fields in the required array, so a missing one is an error, not a silent gap. Use an enum, a fixed set of allowed values for anything categorical like a status that can only be open, paid, or overdue, and write a clear description on each field. The docs are emphatic about this. The description is how Claude knows what actually goes there. A tight schema is the cheapest reliability you'll ever buy. Now, two newer features worth knowing. They go beyond what the original exam blueprint assumed, so I'll flag them as current docs rather than exam guaranteed. First, strict mode. Add strict true to the tool definition, and the model is constrained as it generates, so the output always matches your schema exactly. No missing fields, no wrong types. Second, structured outputs, a dedicated feature separate from tools. You hand it a schema and the final response itself is guaranteed to be valid, conformant JSON. Both push schema checking earlier. They prevent the bad output instead of catching it after. Tool use plus a schema is the foundation the exam tests. These are how you harden it in production. Here's the part people skip and the exam likes it. Even with the perfect schema, validate what comes back. Schema validated is not the same as correct. The shape can be right while the content is wrong, an amount of 0, a due date in the past, an empty vendor string that technically satisfied type string. Your schema guarantees the structure, your own validation guarantees the meaning. Check the values against your actual business rules before you trust them. Treat the model's output as input to your system and you validate input. When validation fails, you don't crash and you don't silently accept garbage. You close the loop. You hand the error back to Claude and let it correct. The documented way, return a tool result marked as an error with a specific instructive message, not just invalid, but amount must be greater than 0. Given that, Claude will typically fix it within a couple of tries. Two rules make this safe: write error messages that say exactly what to fix, and cap the attempts 2 or 3, then fall back to a human or a safe default. An unbounded retry loop is just a slow, expensive way to hang. Let's apply it. Scenario 6. A system extracts fields from messy invoices into a database. Vendor, amount, due date, line items. The model sometimes replies in prose, sometimes returns JSON with a missing field, sometimes the wrong type. What's the most reliable design? Option A. Add return JSON only to the prompt, then parse the reply, and if parsing throws, resend the whole prompt. Option B. Prefill the assistant's reply with an open brace to force it into JSON. Option C. Define an extraction tool with a typed input schema. Required fields, enums, descriptions, force it with tool choice, read the tool use input, validate it, and on a bad value, return an error tool result so the model corrects. Option D. Raise max tokens and lower the temperature and hope the JSON comes out cleaner. Walk it. A return JSON only still leaks prose, and parsing it by hand is the fragile seam we opened on. Resending blindly doesn't tell the model what was wrong. Gone. B. Prefilling the brace is the deprecated trick, not the documented path on current models. Gone. D. Temperature and token limits don't give you a contract. You're still hoping. Hope isn't a design. Gone. C. A typed schema forced through tool use, read directly, validated, with a specific error fed back on failure. That's every technique in this episode in order. That's the answer. Lock in 4 things. Don't parse the model's prose. Define a contract. A JSON schema attached through tool use. Claude returns a tool use block whose input already matches your shape. Make it reliable. Force the tool with tool choice so you never get prose, and design the schema types, a required list, enums, and a description on every field. Skip the deprecated tricks. There's no JSON mode switch. Schema valid isn't correct. Validate the values against your business rules, because the right shape can still hold wrong data. And close the loop. On a failure, return an error tool result that says exactly what to fix. Let Claude retry, but cap it at 2 or 3 attempts and then fall back. In production, strict mode and structured outputs harden this further by preventing bad output at generation time. That finishes domain 4. Next episode is domain 5, context management and reliability, the 15% that quietly decides who passes. Subscribe, and I'll see you in episode 10. Picture a long agent run. Early on it's sharp. 40 steps later, the context is almost full. It's quietly forgotten the instruction you gave at the start. Every step costs more than the last, and then one tool call fails and the entire run dies. 20 minutes of work gone. Nothing there was a prompting problem or a tool design problem. It's the part most people never study, managing the context window and engineering for the fact that the model and its tools will sometimes fail. Welcome back to the CCA exam prep course, episode 10, domain 5, context management and reliability. It's only 15% of the exam, the smallest domain, and is the one that quietly decides borderline passes because almost nobody prepares it. Same honesty note, the public exam guide details domain 1 only. So this is mapped from Anthropic's docs. 2 ideas hold the whole domain together. The context window is a finite budget you have to curate, and the model is a probabilistic part you have to build around. Start with the window. Everything Claude can see on a given turn lives in one finite budget, the context window. On the newest models, that budget reaches 1 million tokens. On the everyday workhorse models, it's 200,000, big but not infinite. And it's shared. Your system prompt, every tool definition, the entire conversation history, every tool result that came back, and any documents you pulled in, they all draw from the same budget. A long agent run is constantly spending it, turn after turn. One useful detail the docs call out: the newer models can be given awareness of their own budget. They're told how many tokens they have and how much they've used as a run goes on. So manage the context isn't just your job on the outside, the model can reason about it too, but the architect still owns the strategy. Here's the counterintuitive part the exam loves. Filling the window is not the goal. As context grows, accuracy actually degrades. The model gets worse at finding and using what matters. Anthropic calls this context rot, and it's measurable. Bloated, unpruned history can drop retrieval accuracy by around 30%. Facts in the middle of a huge context get lost. So, the move is the opposite of stuff everything in just in case. Relevance beats volume, curate what's in the window, and pull information in just in time. By holding lightweight references like file paths or queries and fetching the actual content only when a step needs it, instead of preloading everything upfront. But long runs fill the window no matter how careful you are. The answer is compaction, summarizing the conversation so far into a tight digest and continuing from that, instead of dragging the full transcript along. In Claude Code, this is built in a compact command you can run yourself, an automatic compaction that fires as you approach the limit, replacing the history with a structured summary that's a fraction of the original size while keeping your instructions and memory intact. On the API, there is a compaction feature for agents too, currently in beta. The principle to remember for the exam: keep the thread of what matters, the goal, the decisions, the open loops, and drop the raw transcript. Next, a tool that's about cost and latency, not accuracy: prompt caching. In a long session, you resend the same big stable prefix every turn: the system prompt, the standards doc, the schema. Paying full price to reprocess that every time is waste. With caching, you mark that stable prefix once, and subsequent turns read it from cache roughly 90% cheaper than reprocessing and faster. The cache leaves for a few minutes by default with a 1-hour option, and it only kicks in above a minimum size. The rule of thumb: put the stable reused content at the front and cache it, keep the part that changes each turn after it. That's how long agent sessions stay affordable. Now the reliability half. The model is probabilistic and tools fail. So a reliable system is one that expects both. Start by actually reading why a response stopped. A normal stop reason isn't an error. It might mean the model finished or wants to call a tool or hit the token limit and needs you to continue, or refused, each of which you handle differently. A request error is separate, and that's where you retry with backoff. Around that, the standard agent guardrails bound the loop with a maximum number of turns so it can't run forever. Retry a failing tool a few times, then stop and fall back gracefully to a safe default or a human instead of crashing the whole run, and write tools that handle their own errors rather than punting a raw stack trace back to the model. Failure isn't the exception to design for later, it's the normal case. Last piece, and the one that separates a demo from a product: evaluations. Reliability isn't a feeling, it's a number you track. You build a set of test cases, run your system against them, and grade the results. Two things make evals real: mirror the actual distribution of work, not just the happy path, include the messy cases, irrelevant input that's too long, ambiguous requests, even adversarial ones, and pick a grading method that fits. Exact code checks where you can, a model grading against a clear rubric where you can't, humans only when you must. Then every prompt or model change is judged against the suite, not against vibes. You can't improve what you don't measure. Let's apply it. Scenario 3, a multi-agent research system that runs for many steps, piling up search results and sub-agent outputs. Over a long run, it gets slower and pricier. starts contradicting its own earlier findings, and now and then a sub-agent's tool call fails and the whole run aborts. Which set of practices best fixes this? Option A. Just move everything to the million token model so it all fits and let the run go as long as it needs. Option B. Compact the accumulated context as it grows, retrieve sources just in time, cache the stable prefix, bound the loop with the max turns limit, retry failed tool calls with backoff, and fall back if a subagent keeps failing, and run evals to catch regressions. Option C. Lower the temperature and add be reliable and consistent to the system prompt. Option D. Catch the tool error and just retry the same call over and over until it finally succeeds. Walk it. A bigger window doesn't save you, it invites context rot. The contradictions get worse and the cost climbs faster. Size isn't a strategy, gone. C. Temperature and a be reliable instruction touch none of it. Not the context, not the failing tool. Words aren't reliability, gone. An unbounded retry is just a slower way to hang, and it ignores the context problem entirely, gone. B. Compact and retrieve and cache to manage the budget, max turns, bounded retries, and a fallback to survive failure, evals to keep it honest over time. That's the whole domain applied. That's the answer. Lock in 4 things. The context window is a finite shared budget, and bigger isn't better. Context rot means relevance beats volume, so curate what's in the window and retrieve the rest just in time. For long runs, manage the budget actively, compact the history down to what matters, and cache the stable prefix to cut cost and latency. The model is probabilistic and tools fail, so read the stop reason, retry with backoff, bound the loop, and degrade gracefully instead of crashing. And measure it, build evals with real world and edge cases, and judge every change against the suite, not against vibes. That's all 5 domains covered. From here, the course turns practical. Next episode, we dissect all 6 exam scenarios, 1 worked question each, so you walk in knowing the shapes. Subscribe and I'll see you in episode 11. You have all 5 domains now. This episode turns them into reflexes. The exam describes 6 scenarios and draws 4 of them at random for your questions. So if you know the shape of all 6, there's nothing on the screen you haven't already seen. And here's the pattern worth catching early. Every one of these scenarios rewards the same handful of instincts you've been building. Watch them repeat. Welcome back to the CCA exam prep course. Episode 11, all 6 scenarios, 1 worked question each, frame the way the real exam frames them. Same honesty note. The 6 scenarios come straight from the exam blueprint. The worked questions are mine, built on the domains we covered. Let's go. Scenario 1, the customer support resolution agent. It looks up orders, drafts in brand replies, and can issue refunds, but a refund over $500 must never go through without a human. What's the right design? The tempting trap. Put never refund over $500 without approval in the system prompt. It feels handled, but that's guidance. And a hard money limit is a guarantee. A prompt can be talked past. The answer: enforce the $500 limit in the refund tool's own code. Give explicit reply criteria plus a few in-tone examples, and let the agentic loop handle the lookups. The guarantee lives in code. The tone lives in examples. That's domain 1 and domain 4 in one question. Guidance versus guarantee, and prompting for the parts that are genuinely probabilistic. Scenario 2, a team generating code with Claude Code. It has to follow the project's conventions, must never modify the infra folder, and there's a large risky refactor coming. Best setup. The trap. Paste the conventions at the start of each session and politely ask it not to touch infra. That doesn't persist, it drifts per developer, and please don't is still just guidance. The answer: commit a project CLAUDE.md with the conventions, add a settings deny rule on the infra folder so the restriction is enforced for everyone, and use plan mode before running that risky refactor. Pure domain 3 scope decides reach. A guarantee goes in a deny rule and you plan first when the blast radius is large. Scenario 3, a multi-agent research system. A coordinator spawns research subagents over a long run. Over time, it slows down, starts contradicting its earlier findings, and sometimes one subagent's failure takes down the whole job. Best design. The trap. Pour everything into one giant single agent with a huge context window so it all fits. That's context fraud waiting to happen, no real parallelism, and one failure still kills everything. The answer: a coordinator with subagents that each work in their own isolated context, summarize results back instead of dumping raw transcripts, bound the loop and retry, then gracefully fall back when a subagent fails. Domain 1 meets Domain 5, isolate and orchestrate the context, and engineer for the failures you know are coming. Scenario 4, developer productivity. A team wants every developer to run the same review this pull request workflow the same way without re-explaining it each time. Best approach. The trap that looks productive. A long section in CLAUDE.md describing the review steps, but that bloats memory on every session and nobody invokes it on demand. It's always on context for an occasional task. The answer: a checked-in/command.claude/command/review with the steps, the allowed tools, and an argument hint. Everyone runs the identical workflow with one command. Domain 3, again, memory is what Claude always knows. A command is the repeatable workflow you invoke when you need it. Scenario 5, Claude Code in CI. The team wants every pull request reviewed automatically with no human kicking it off, and the job must never modify the repo or reach outside it. Best setup. The trap: run it with permissions bypassed so nothing ever blocks the job. Against a real repo, that's exactly the thing you never do. It can change or reach anything. The answer: run it headless on the pull request trigger with an allow list limited to read and comment, a no ask mode so anything else is denied rather than hanging, and the API key in secrets. Domain 3's reliability age. With no human to approve, you pre-install the break, least privilege, and deny wins. Scenario 6, structured data extraction. You are pulling fields out of messy documents into a database, and the model keeps returning prose, missing fields, or the wrong types. Most reliable design. The trap: tell it return JSON only, parse the reply by hand, and resend the whole prompt when parsing fails. You are scraping prose again, and a blind resend never tells the model what was wrong. The answer: define a tool with a typed input schema, required fields, enums, descriptions, force it with tool choice, read the structured input directly, validate the values, and feed a specific error back on a bad one. Straight domain 4, don't parse prose, fill a contract, then validate it. Step back and the whole thing collapses into a few instincts. Ask of every rule, what scope, and is it guidance or a guarantee? And put guarantees in code, not prompts. That alone decides scenarios 1, 2, and 5. Least privilege is always the safe instinct, especially when there is no human in the loop. Scenarios 2 and 5 again. For output, reach in order, explicit criteria and examples, And when you need structure, a schema you validate. That's 1 and 6. And for anything long or multi-agent, isolate and manage the context and engineer for failure, bound, retry, fallback. That's scenario 3. Recognize the scenario, reach for the instinct. That's the whole exam. The last episode pulls it together into exam day strategy, how the distractors are built, how to budget your time, and the practice test score that actually predicts a pass. Subscribe and I'll see you in episode 12. If you followed this course, you've done the hard part. 5 domains, 6 scenarios, the material is in your head. But the exam isn't only a test of what you know, it's a test of how you take a test under a clock with 1 attempt. That last gap is exam craft and it's very closable. 3 things close it. Reading how the wrong answers are built, budgeting your time, and not booking until a practice score says you are ready. Welcome back to the CCA exam prep course, episode 12, the finale. One honest note up front, same as always, the exam is currently partner gated $99 with a partner discount, and Anthropic has announced broader developer certifications coming later in 2026. So this is about being ready to pass on day 1 whenever your door opens. Start with the rules of the room because a few of them change your strategy. 60 multiple choice questions, 120 minutes. It's scored on a scale from 100 to 1000 and you pass at 720. It's proctored. A single sitting, no outside resources. Results come back in about 2 business days. And 2 facts that should shape how you play it. You get 1 attempt, so readiness matters, and an unanswered question is simply marked wrong with no penalty for guessing. Hold on to that second one, it has a direct consequence we'll come back to. Now, the most useful skill for this exam, reading the distractors. The wrong answers aren't random, they are engineered to be tempting, and they come in a handful of shapes you've already met. There's the one that puts a hard rule in a prompt when it needed a guarantee in code. The one that throws a bigger model or a bigger context window at a design problem as if scale were a strategy. The one that reaches for a knob, temperature, or max tokens instead of a design. The one that bypasses permissions so nothing blocks convenience over safety. And the one that just asks more emphatically louder instead of explicit. Once you can name those shapes, half the wrong answers light up before you finished reading them. That turns into a technique. Don't pick the answer that feels right. Eliminate the ones that break a principle you learned. Almost every distractor violates exactly one rule. It confuses guidance with a guarantee, or ignores least privilege, or parses prose instead of a contract, or lets context rot. So go option by option and ask one question. Which principle does this break? 3 of the 4 will break 1. The one that breaks none is your answer. You are not recalling trivia. You are applying the same instincts from the scenarios episode, one option at a time. That's the whole game. Now the clock, 60 questions in 120 minutes is 2 minutes each on average. Comfortable, but only if you don't sink 10 minutes into one stubborn question. So work in 2 passes. First pass, answer everything you are sure of, and the moment one fights you, put down your best guess, flag it, and move on. Second pass, come back to the flagged ones with your remaining time. And here's where that earlier fact pays off, because a blank scores the same as a wrong answer. You never ever leave one empty. Every question gets an answer, even if it's a flagged guess. Which brings us to the single most important habit before you book the practice exam. Take it and treat the score as a readiness signal. The pass line is 720, but your target on the practice test is over 900, not 720. Why the gap? Because you have one attempt and a real exam is always a little harder than practice nerves, the clock, unfamiliar phrasing. A practice score hovering around the pass line means you're not ready yet. It means go back to the domain where you're losing points, aim for 900 in practice and 720 on the day takes care of itself. On the day itself, a few small things keep you out of your own way. It's proctored, so set up a quiet room and have your ID ready before you start. When a question loads, read the scenario before you read the options, decide what good looks like first, then go find it, run your 2 passes, answer every single question. And the mindset, you've already seen all 6 scenario shapes and every principle they test. Nothing in that room is new. Calm operator, not anxious guesser. That's the posture that passes. So that's the course. Pull the whole thing into one breath. The 5 domains, the Agentic loop and orchestration, tool design and MCP, configuring Claude Code and its workflows, prompt engineering and structured output, and context management and reliability. The instinct underneath all of them, ask what scope and whether it's guidance or a guarantee, default to least privilege, make the model fill a contract you validate, and manage context while engineering for failure. And the exam craft from today, name the distractor, eliminate by principle, run 2 passes, never leave a blank, and don't book until practice clears 900. That's everything you need. This was a free course because the best version of this material shouldn't sit behind a paywall. So if it helped, the playlist is the whole thing in order, and you can find me on X and GitHub in the description. Go get the badge. Good luck and thanks for watching. Subscribe if this earned it, share it with someone studying, and I'll see you in the next series.